Good afternoon, everybody. I'm Mike Herta. I'm Associate Director of the National Library of Medicine for Strategy. I welcome you to Session 2, Curation in the Ecosystem of Science and Scholarship. I'll note that the session will not have a panel discussion at the end, so each of the 4 speakers will have a total of about 20 minutes for presentation as well as Q&A. And to keep us on time, I will turn on my video on the 18-minute mark and probably say something like 2 minutes left for the speaker to wrap up. And with that, let me introduce our first speaker, Dr. Melissa Handel. She is the Chief Research Informatics Officer at the University of Colorado, Anschutz. Dr. Handel's Translational and Integrative Sciences Laboratory is expert in semantic engineering and data harmonization, and they've led a number of large-scale curation programs, including the Monarch Initiative, the Biomedical Data Translator, and the National COVID Cohort Collaborator. Her research background is in molecular genetics, developmental biology, and translational informatics. And today she'll tell us about several efforts and approaches to attaining large-scale, enterprise-level interoperability. Melissa?
Thank you very much. It's really an honor to be here. Let's see, how do I share? And we'll get going. Let me know, Mike, if you can see my screen. Great.
Looks good.
Awesome. So these slides are also posted at that bit.ly for those that are interested. There's a number of links in the deck. So when I get done, I'll also post a link. So I'm going to talk today about curation pipelines at scale and mention a number of different projects, but basically how do we realize interoperability at an enterprise level? So interoperability is in the eye of the beholder, and curation is key to this. So curation can apply to many different aspects of interoperability. So for example, legal and licensing. So restrictively licensed data can only be combined with permissibly licensed data. And we've had a big initiative over the last several years to curate licenses for data, not just for use, but for reuse and redistribution. And it turns out to be quite challenging, in part because of a lack of consistent curation of data licensing. Second is regulatory. So understanding how access control mechanisms match the provenance regulatory permissions. So essentially aligning a user's permissions with each data item, which becomes increasingly challenging when data is integrated to keep track of all of that and reliant on curation of all of those different aspects. And the Duo ontology developed in the context of GA4GH has really helped move the needle on that one. Then there's system level interoperability, where platforms and tools often cannot talk to each other in order to move data and analyses from one to another. Again, lots of great activities in the GA4GH and other contexts, commons ecosystem efforts and the like. And finally, data, which is really the subject of my talk today, that data is often unencoded or coded in different data models and terminologies, which really limits search and integrated analytics. So standards adoption and curation to them is not keeping pace with the volume of data being produced. Fundamentally, data interoperability is really dependent on various kinds of curation that really help us overcome this standards and curation gap. So if we think about distributed data, we can have rich, high quality data and understand something about each silo, if you will. Maybe we want to understand something about the San Francisco skyline on a sunny day, but then we wouldn't necessarily know anything about San Francisco Bay when it's 15 degrees Celsius. And so some examples would be species specific or data type specific. We can aggregate data, and there's lots of data aggregators, and that can support large scale indexing and general search and retrieval. But it's really when we have integrated data that we can see the picture. And for biology and medicine, this is particularly important. We really need to understand things. Not only do we have an interest in putting the pieces of the bridge together, for example, but we need to know where the edges are, the corners are. We need to know how to put the picture together. And so careful alignment of distributed data towards shared conceptual frameworks using consistent identifiers, shared data models, shared terminologies, and other exchange standards can really help us do that and build this big picture view with cross-domain insight by both humans and machines. So curation at scale requires solving the mapping problem. This is both at the schema level and the value level. So just wanted to kind of describe this because I think when people talk about mapping, they're usually talking about one or the other, or sometimes both in a conflated way. So if we take these two fabricated schemas, they have some common elements in common. So for example, we have this peachy colored box, and we have this green colored box, and the green colored box has values in it. So this would be like a set of enumerations or value set of terms. And those terms, are filling a sort of a field, if you will, in the schema, or a table in the schema. And the way that table or that field in the schema aligns with the rest of the schema is different than it is over here on this example here. And so we need to map, the pink boxes that are the schema level relationships, as well as the enumerations and values that are in those schemas. So some examples to kind of illustrate this challenge, because they really have to kind of go in concert. This is an example from the Cancer Research Data Commons, where each CRDC node has a different schema, models things differently. So for example, in one node, there was no direct link from sample to diagnosis. And so we would need to remodel, if you will, sample to case relationship, the diagnosis to case relationship, to align it with the sample to diagnosis relationship. And then on the terminological side, you can think of that sort of set of values that you might have in, say, a diagnosis. And here the example is reporting race, where one node reported race with this list of terms, not reported white, American Indian, or Alaska Native, Black, or African American, while another one has this set of terms. And you can see some of these match, so white matches in terms of its string, but there are many other issues here. So is not reported the same as other, or not allowed to collect? And the curation rules that we use to map these things when we want to convert a set of terms that looks like this to a set of terms that looks like that, or vice versa, have to be captured in a fully provenanced way and in a well-justified set of curation rules. So mapping is all over the place. It's lossy and it lacks provenance. So we talked a little bit about the enumerations, and those many times come from source terminologies, although they can also be free text. There are a lot of different efforts to map terminologies to each other, such as the Odyssey community, the MLS, the NCIT. And so this is really mapping one terminology to another. We have coded data, which transforms one code system or one terminology to another. But then we also have that free text, like I showed with the enumerations on the previous slide, and trying to map that to a structured terminological entity. And then we have sets of things like those races on the last side. And those are exchangeable terminology artifacts as well. And so how each of these arrows or sets of things are generated requires curation rules and provenance. So here's some examples in the links that I mentioned earlier that are some key tooling to try to achieve data interoperability across these different contexts. So obviously ontologies, which is our semantic or data context with predefined ontology concepts. The Mondo disease ontology unifies, is another mapper, but it unifies diseases. I'm going to give an example about that. And a variety of other ontology and terminology standards that are listed there. For data models, this is syntactic. This is the data language, which is via predefined data models, data structures, data dictionaries, and other schemes. We have developed a modeling language called LinkML, but there are many others such as OMOP, Bridge, bioschemas. And then data formats, which is really how the system has data presentation via common data formats. So one of the ones that we've developed to help improve sharing of mappings in a more fully provenanced way and encoding those curation rules is the Simple Standard for Sharing Ontology Mappings, or SSSOM. But there are many other formats for sharing different kinds of things, such as OWL, RDF, JSON LD, BCF, FASTA, et cetera. And then finally, exchange. So data architecture, how do we exchange data via networks, computers, applications, and web services? We heard Peter Robinson's earlier presentation on Phenopackets this morning, but also APIs, Docker, and FHIR. So this example is on harmonizing terminologies across sources and why curation at scale is so important to align terminology. So there are many different disease terminologies. And this, in the Monarch Initiative, we needed a comprehensive set of disease concepts that spanned many different categories and a systematic way of relating them. So why not just use mappings? Many terminologies, ontologies, or lists include mappings, and these can certainly be used to crosswalk, but they're often mutually inconsistent. You have n to the set of to n squared sets of mappings, and there's not one-to-one equivalence. And so we developed a method to scale ontology mappings using evidence-based merging of equivalent diseases. So taking a variety of different disease terminology sources using the Bayesian owl ontology merging algorithm called KBOOM, which includes logical and probabilistic inference. So it basically examines sets of terms and looks to see what is the probability of equivalence of a given set of terms. It looks at things like labels, cross-references, synonyms, sources, and just a set of curation rules that might be associated with the particulars of any given source. Excuse me. And so then that generated some initial equivalency between all these different terminologies, which we could then give feedback to those source terminologies. So for example, we found in the mesh terminology that there was a duplicate set of alphanumeric and Roman numeral named diseases. So for example, if you had diabetes type 2 with the number 2 versus the Roman numeral 2. And so that kind of information is fed back to each of the sources, which really improves all of the sources by doing that type of harmonization. And here's the downstream effect of having scaled that. We were interested in understanding how many rare diseases are there actually. The number has been quoted at around 7,500 since the Orphan Drug Act of 1982. And we suspect that there is more rare diseases known since then. And in fact, when we look across all the different sources and have, create in the Mondo resource, we find that many resources have only one disease, whereas only 330 disease concepts were shared in the top 5 commonly used disease sources that we had. So what does this mean? It means that depending on where you live and what resources are being used for your rare disease diagnostics or for your patient portal, that you may or may not have access to disease knowledge about all of the rare diseases. And so working together as a community, the Mondo resource has really brought together all these different terminological resources to improve each individual resource, but also to create a consensus set of nomenclature and associations and equivalency determinations that allow computational integration of disease resources for diagnostics and mechanism discovery. So next I'm going to switch gears and talk about the National COVID Cohort Collaborative, which is really about how do we scale data harmonization. In this case, we have 72 institutions now released in the National COVID Cohort Collaborative, which is a secure HIPAA-limited data set hosted by NIH, and it supports large collaborative analytics with over 3,500 different individuals working together. And what each institution had to do was to essentially say, what is our clinical data best represented in for our institution? Many institutions have more than one common data model. And so institutions were able to push data to the NIH Enclave in OMOP, ACT, Trinetics, or BCORnet. There's a few custom additions, and then also we're working on a FHIR interoperability as well. And so essentially, these data are pushed to NIH. They go through a parsing step. We apply a common data model schema, which is OMOP as a target model, and basically manage the full provenance of this pipeline and all of the quality assurance checks, all of the field mappings and value set mappings to perform this harmonization are all released in GitHub. And the enclave now has over 12 million persons and over 4 million COVID positive persons with over 14 billion rows of data, making it the largest limited data set for public research in US history. And this is really a testament to the very, very large number of people who participated in helping realize this harmonization. And so, what does this really entail? It's essentially scaling the manual curation bits of mapping that I talked about earlier in the talk to scaling it with data sets that are this very large and also are sensitive data that must be kept behind a secure firewall. So ensuring that harmonization rigor comes with this scalable requires continuous monitoring and provenance. So for every single transform that's performed on every single individual site's data set, we can track the full lineage and provenance of that harmonization now for 72 sites and over 5,000 transforms. The pipeline is versioned and deployed with upgrades and automated data quality checks for every new site as well as existing sites. And curators and developers can therefore quickly identify and address the issues. It's also quite scalable, and the pipelines can be refreshed in less than 20 minutes. And so what you see below is just a portion of each of the transforms for one individual site. So one thing that I wanted to remind everybody is that when you do scale data harmonization to this extent, you need to remember that it's harmonized, but it's not necessarily homogeneous. Different common data models have different expressivity and include different things. And this is just an example where, for example, we're trying to understand how to best support death data. And in Odyssey, the death date is required, whereas in pCoreNet it is not. And the same is true for Trinetics and ACT. And so just because it's harmonized doesn't mean that we're going to see the same representation in terms of data population in that later context. And this turns out to be quite important to keep in mind when doing analytics. You may wish to remove specific sites or remove specific variables from your analyses based upon an understanding of what's happened upstream in terms of populating these models with the source data. So scaling data quality assurance, I wanted to talk a little bit about federated versus centralized data quality. It turns out that we have some really interesting advantages in the context of a centralized data set. So in the clinical community, there exist a number of different clinical research networks that are functioning in a distributed fashion where the clinical data stays behind each institution's firewall. And so for performing data quality, this is challenging because questions regarding data quality are sent to the partners execute those queries and reports, and then send the results back. In the centralized context, we can actually perform that quality assurance across all the sites at once. And I'll show you a few examples. So this is unit harmonization. So in this case, we are harmonizing units across the site. And you would be surprised at how many errors there are in units. So it turns out humans measured in grams really do not look the same as humans that are measured in kilograms. And so oftentimes we'll see something that's listed in grams or kilograms when it was really meant to be pounds or ounces. And based upon a set of curation rules, we can actually repair a lot of these units to their correct units and then thereby harmonize those data. And so this table just shows a variety of different units that have been harmonized with the blue, the light green being the proper units being utilized. And this is the percentage of measurements from that from across the sites. Whereas the blue are the repaired units. So in many cases, for many of these particular measures, such as pH, we're able to repair an enormous number of the units to meet those data quality standards. And this makes for 2 times as much usable data in the end. Just to give you a couple other examples of the kinds of things we can do when we scale data quality measures for a centrally curated, harmonized data set. These are 16 of our sites. And you can see, we're just looking on the left at different ways of saying that somebody has COVID or not, and what each site is actually representing. And so you can kind of see how different sites represent a positive case versus a negative case. There are different codes for those. And there are different ways of representing that. Other kinds of things that are looked at for data quality across the sites, number of COVID tests, and the proportion of positive to negative. So if we see a huge skew at one site, we know something's wrong. The average number of rows of data per patient, the conformance to OMOP standards, plausible demographic distributions, and visits with negative links. And that's just the tip of the iceberg. So I wanted to also just speak really briefly to the fact that it takes a village. This was our first paper for the N3C, and I can't possibly thank all the people that participated in all of the activities that I mentioned, because there are literally thousands of them. However, what's really exciting in particular about the clinical data harmonization context in N3C is that, unlike genomics and some other fields where, journals are really accustomed to large team science, clinical informatics has not historically been that way. This was our first paper in JAMIA, and it took us over a year. There were 199 authors on this paper. And it took us over a year to help JAMIA work with Medline to get each author indexed in Medline so that their records would show up in Medline and in MyNCBI. So it's really a great opportunity to kind of grow capacity in clinical informatics and team science in that context. And also
2 minutes left.
Also thank you, Mike. Also in the context of attribution and really supporting how we attribute all the many hands that it takes to do this kind of enterprise curation at scale. And so many thanks to the entire community. So with that, I have a couple minutes for questions.
Thanks so much, Melissa. There's a question in the Q&A. How do you share problems or improvements you've identified with source terminologies, ontologies, like your example with Mondo and Mesh? How do you share that info?
So in the Mondo GitHub tracker, we track all of the issues there. If the source terminology is an active participant in the creation of Mondo, we will just have the conversation in that GitHub tracker. But we also work with each source terminology's existing resources for however they go about receiving feedback. So for example, NCI has a feedback form that we submit tickets to NCI, and they often comment on our ticket tracker as well. And we have regular meetings as well where users come and we work through the details, because sometimes there's errors on many sides and people don't actually have the right answer, and so it requires community effort. And then those efforts are well documented and included on our GitHub repository.
Great, we've got time for one, and the question is whether the N3C is going to be used for long COVID research.
Yes, it is. We are part of the Recover program. We actually just published our first long COVID paper. I'll put the link to that in the chat as well. And it's proven really, really effective to have so much data to study long COVID in the face of a new disease where we don't really understand the full characterization, especially with the hypothesis that long COVID is really multiple different subtypes. And so really working hard to understand how can we define those subtypes and then thereby reveal underlying mechanisms and potential therapies for those subtypes.
Great, thanks so much, Melissa. There are a few more questions in the Q&A. If you could just type in the responses, that'd be great. Thank you. We'll now turn to our next speaker, Dr. Allison Lister. She is the Fair Sharing Coordinator for Content and Community at the University of Oxford Department of Engineering Science. She started in biology, but quickly crossed the divide into data science, working first for Uniprot Tremble at EBI, and then working in semantics and ontologies in the contexts of systems and synthetic biology at Neil Weipat's group at Newcastle University. Today, she'll be talking about curation approaches that blend different techniques and different types of curators. Allison?
Thank you very much, Mike. I appreciate you inviting me along, and I look forward to telling you all about the type of large-scale curation we do here at Fair Sharing. The classic, can you see my slides?
Yes.
Perfect. I shall get going then. So thank you for that introduction. I really want to focus on one word in my title today, which is ecosystem. I'm going to talk to you today about how we curate a real ecosystem of research standards and databases. And the relationships that we create within fair sharing are really my favorite parts of fair sharing, and it's where the curation gets really interesting. So what is fair sharing? Very briefly, in the smallest of nutshells, fair sharing provides a curated description and set of relationship graphs of the standards, the databases, and policies across all research domains. And what really connects them are the different ways in which you can get from a policy to a standard to a database and to the organizations and users related to it. Today, I want to focus on what within fair sharing we find is the most complex challenge is the curation of our relationships across resources themselves, across organizations, and within and across domains. Resource level curation is really a jack of all trades situation, and it requires curation that has an eye for the collaborations, an eye for the community, an eye for interoperability. And it's really focusing on this constantly evolving landscape of standards, databases, and policies. And what I'm going to do is I'll explain a little bit about this resource level curation, then move on to the challenges that we all face when we're dealing with curation and biocuration, and then go on to the solutions that we get from the community that we serve. And that includes outreach, attribution, partial automation, and flexibility. So what I want to do first is just focus on that resource level curation. So rich curation is available at all levels of granularity. Here I've taken a screenshot from Wormbase, but fair sharing occupies a different place within the traditional data curation scene. So expertise moves from the depth of data level curation within a particular domain through to this sort of all-purpose breadth, the width of resource level curation across all research areas and all research types. So our connections are developed along two axes. That's the axis of the human connectivity through a collaborative user community and resource connectivity through our richly described resource relationships. And our community works with us to ensure that their resources are described accurately and fully because they get in return a valuable tool for resource promotion and discovery. So what are some of the ways that they use fair sharing to showcase their communities? Well, we create tailored views with them to educate their community and promote the resources within their community. And these tailored views happen via collections, which are branded pages that group standards, repositories, and policies. Societies, initiatives, projects have all created them for a variety of different purposes. For example, to list resources developed by a community or a standards development organization, recommended by that community, or indeed when crosswalks are generated across different metadata schemes, then we can represent those described schemes within a collection. And if we go a little bit closer into some more examples, I can really cover how collections provide both context and connectivity. This is an example of the ISO standard for biotechnology, which is a specification currently in development. And it shows the vast number of standards really that are represented and listed within this specification document. And looking at a flat list of standards within a specification is tricky at the best of times. But what fair sharing does, and what it did with the authors of this standard, is create an overview, a dynamic landscape of those standards that are represented. And you can see we actually cover here the life cycle status of each of the resources within, because it's this live display of a static specification where you really get an idea of what's going on in this community of interest. Another example I've shown here is with PLOS. So these are the recommended repositories provided by PLOS. And what you have is less connectivity because they're not always related because they're in different subdomains, but the connectivity you get is really quite interesting. And it's important to note that relationships are central to fair sharing. Once again, I'm telling you that this is my favorite bit, and this is the bit where we really get a complexity challenge, but also a really great opportunity, because we can navigate and we can go down the rabbit hole of Wikipedia traversal, and we can use it in the same way with our relationship graph. So you can find the Wormbase subnetwork within the PLOS recommended repositories and expand upon that and come onto the Wormbase network itself. So this is a dynamic system. It's of interconnected resources to showcase the interoperability and improve the findability of not just Wormbase itself, of course, but it leads you through into all of the relationships it has and the collaborations, associations, what databases are related to it, what standards it implements, what of those standards are still ready, which ones have been deprecated, which ones are in development. And you can see a lot of information condensed into a small space. We can also then carry on further down the rabbit hole and see MGI, see which subset of the MGI network is also represented within the Wormbase network, and find those areas of collaboration. Now, that's a really high-level overview of the resource level curation and how the relationships present a picture of a dynamically evolving system of interconnected resources. I've also said how those relationships present both a curation challenge as well as an opportunity for resource discovery and for descriptions and interoperability. But now I'm going to focus a little more on the challenges before we proceed to the solutions, okay? And responding, it's important to note, to these changing requirements and challenges isn't just a technical issue to represent on the site, but is also a big curation challenge. So the first thing is scarcity. Unfortunately, very unfortunately, curator numbers do not follow Moore's law. So every 2 years, we don't get a doubling in numbers of curators available for our repositories. And I'm sure that all of you are very well aware that our repositories are growing. Our registries are growing, but curator numbers still remain scarce. That's the first challenge, yes? And the second one is resource level metadata. It itself has an increasing scope, and what we're getting is we're getting a lot of third-party tools, especially around fair evaluation and fair assessment, coming to fair sharing because we provide metadata on standards, we provide metadata on repositories and on policies. And this metadata is the sort concerning curation and data preservation that's vital for those FAIR tools to use to help to make a determination and assessment. So we also have, I've just accidentally skipped past the most busy slide in my entire presentation, but that's because this is illustrating the complexity challenge. So what we've got here is the addition of new fields in response to changing requirements. It's not just a technical, but a curation issue, because you put a new field in, you have to curate it. And more communities than ever before now are seeking consensus on what attributes to describe for their standards, for their databases, for their software repositories, even for their policies, as I'll show you in the next slide. And we need to be flexible in response to these community work efforts. And ultimately, when they reach consensus, one of the big curation challenge isn't just the relationships as I've talked about, but really elucidating and identifying these attributes and adding them to fair sharing for the benefit of everyone. And just to give you a short overview on a slightly less dense slide about the various policy attributes checklists that are being developed over the years. We've had the Center for Open Science with their top guidelines, and we've had the RDA working towards data policy standardization, and just this year with Joy Davidson and FAIR's FAIR working towards a FAIR data policy checklist. All of these different repository attributes and software attributes and policy attributes, they have differences in scope, differences in granularity, but they do have a number of common goals. They want to improve clarity, increase alignment and comparability, and better guide researchers to manage and share their digital objects, which ultimately enables fair data. So these are the challenges that we face. The research community is heavily invested in solving issues relating to common sets of core attributes, relating to interoperability and findability, relating to fair assessment and evaluation, discovery of resources and interoperability within their community. But with great challenges comes great opportunity, and fair sharing is perfectly placed to help the community realize these goals. Through the program I will cover next, I will show how our current solutions to these challenges can help us and help the community that we're all a part of. So first of all, reducing scarcity. And we do that through community. We have what you might call a positive feedback loop between us and our curator and maintainer community. And we work not just with researchers who come to us to find a resource or standard to use, but also the research support roles such as data stewards and librarians and trainers. We also work with policymakers and funders and grassroots organizations to really see what they need and make sure that we're describing the community that they are a part of. So we also have another way of looking at the issue of scarcity and looking to what happens when we start increasing the scope of our metadata. And that's a brand new feature that I'm really excited about called our Content and Community Curator Program. I know it's a lot of C's, but it actually rolls off the tongue pretty well. And what we're doing here with our early adopters is that we're asking them to look at their domain, their expert domain within Fair Sharing, and see how the coverage is and see how the completeness is, and help us curate these domains. So, and in return, not only are they gaining on-the-job expertise, engagement, and networking with a community of like-minded people, but they're also becoming an expert on the data and metadata standards within their area, the repositories and data policies within their domain. And they're also influencing Fair Sharing in return. As we develop new features, we get their feedback and we ask for what new features they need. And most importantly, as part of this give and take with our new community curation community, we are also looking at attributing. I love our user community, our maintainer community, and I love trying to find new ways of making sure that they're attributed for the work they do. And right here, I'm going to pause and say, wait here, and just for a little bit longer over the next few weeks, you're going to see some exciting news coming out in relation to this kind of community building of a curation program within Fair Sharing in the context of the RDA and EOS future. So moving slightly on now to another way that we show attribution, not just by talking about community curation program itself and promoting it, but also by attributing organizations and attributing maintainers, because organizations and users in Fair Sharing in our new data model are now first-class citizens. They are now promoted and having their own pages. And these pages provide all the information that really is exciting and to do with more relationships, because we come right back to that relationship information that's just so important when you're looking at a whole ecosystem of resources. And that's because what you have is you have the links between organizations to those records they're associated with. You have the links from the organizations to the users, and we have the users linked to those resources they maintain. In this particular example, we've got Elixir on the left, and on the right, we have Kyle Koppas, our very first community curator within Fair Sharing. We link all of our maintainers who wish to be linked in that way to ORCID, and this allows us to give them more attribution to showcase their ORCID profile on their user page in Fair Sharing. But also in future, as in very imminently in the future, we're going to provide attribution via ORCID, as we are a trusted partner with them through the University of Oxford and Bodleian Library. And that is really exciting for me. We also store all of the edits made by our curators and maintainers, and we're working right now with the feedback we're getting from our community curators to find out exactly how they'd like this micro attribution to be displayed. And moving on and back to this particular user story that Kyle has. Kyle works as part of GBIF and is one of our biodiversity domain community curators and is part of the Bicycle Consortium, which is an EU-funded consortium. And he's curating entries in Fair Sharing, not just to improve biodiversity domain within Fair Sharing, but also to look and gain a sort of landscape analysis of the adjacent infrastructures within Bicycle. And in doing this, for instance, now we're navigating from one of the members out to one of the standards in the network that standard has. You're getting graph traversal, which aids resource discovery, gap analysis, and targeted outreach and engagement for the consortium itself. And so really, it's helping the consortium along in its mission, and in return, they're helping us with some curation. Now, I talked about attribution, and I talked about our community curators and reducing scarcity in terms of curation through the use of our fantastic community. But we also use our fantastic technical, our development community internally, and we do that through semi-automated curation. We have a collaboration ongoing with OpenAIRE to access our repository metadata in the OpenAIRE research graph and expose it to the European Web of Services and Data. Now, this is interesting because nearly 60% of fair sharing records after this mapping are still unique. They're not in the research graph yet. And that really shows you of the interesting, even when there's already databases and registries present in that research graph, how many more are available through fair sharing. We're also doing a mapping against ROR because that's been a long time coming. But what it does is it shows the different levels of granularity. We've done a lot of work with natural language mapping and iterative curation, combination of manual and automated. And what we've seen is that even though ROR has over 100,000 organizations and we have over 3,000, what we're getting is that over half of our organizations are still unique after the mapping. And that's really because ROR only allows top level entities, whereas fair sharing really works at a granularity level that's relevant for the community. And if a community needs a department or a grassroots organization or a society, then we make the organization for it. I wanted to talk a little bit about the community consensus around database attributes, policy attributes, even standards, well, software repository attributes. We have a flexible data model in our brand new fair sharing system, and that allows us to refine the fields that we've got and expand where needed. And therefore, we're working within the RDA to really resolve this issue around policy attributes here, where I'm not needing to go into the details, but you can see the efforts that were underway with a number of different interest groups and working groups, and also within the data repository attribute working group within the RDA, which is working to condense all of that information on that giant slide that I gave you into a common set of attributes. As you might be able to tell from the slide, I'm one of the co-chairs along with a lovely group of people from all over the world that are working, and we just started this working group. Feel free to join if you're interested in contributing. In summary, what I'd like to say is that we can provide human and machine readable implementations for community agreed checklists and guidance. We do this already. If you pull from our API now, you get JSON formatted metadata at a resource level of curation. And not only that, but when you come to us as human, you can navigate these relationships and really see the ecosystem around your community. And we provide this registration within fair sharing to enable decidability, discoverability, and all sorts of other lovely things. We can prototype and implement a common template for any of these standardized attributes once consensus is reached. And we can engage with stakeholders because we have a very wide and diverse group of stakeholders. People come to us as producers of resources, as consumers of those standards and databases. They come to us from a variety of different backgrounds, funding, policy, research support. But there are also some things to remember about this situation. As lovely as it is for us to work with the community we have and implement their consensus attributes, it does take work, and it is a complexity challenge. Maintaining the description and monitoring the evolution of these policies. Thank you. Of these policies is hard. And can we even reach convergence? All these people are trying. And finally, as everyone knows, curating and describing is not trivial, and these activities need funding. So in summary, as a final note, we are working also towards education, because in the end, education really helps get our user base to understand how to annotate. And not just how to annotate, but once they have a rich description, it really enables the use of the FAIR principles within their user base and enable FAIR data among people who are depositing to them. So I just want to say thank you very much, and thank not just all of you listening, but our current operational team and our stakeholder advisors, our executive advisors, and our lovely group of early adopter community curators. If you think you've got a domain that you'd like to see better curated or better covered within fair sharing, we'd be happy. We are soliciting new members within our community curation program, so please do get in touch. Thank you.
Thank you, Allison. That was terrific. We've got less than 1 minute, so we'll have a question here from Chris Mungle. He says, are you also mapping to Wikidata? or have plans to sync with metadata in Wikidata?
I think we are not mapping right now. I think that's a great idea. I think that also falls under the bottom left box on one of my previous slides, which is the requires funding, because I think it's a great idea. But at the moment, we're responding to what our current community set is asking. And I like Wikidata, but we don't have that on the cards right now, but I would be open to it.
Great. Well, thanks again, Allison. Much appreciated. Interesting.
Thank you.
Let us now go to our next speaker, Dr. Richard Sever. He's Assistant Director of Cold Spring Harbor Laboratory Press and co-founder of the preprint servers bioRxiv and medRxiv. His academic background is in biochemistry and molecular biology, and he's had a number of editorial roles in those domains. Today, he'll be talking about the challenges of discovering and curating preprints. Richard?
Hi, can you hear and see me okay?
Yes, indeed.
Fantastic. Great. Well, I'm going to sort of take the sort of 50,000 foot view of this question really and summarize a few initiatives. But just to start off, I want to make clear what I mean when I say a preprint. And what we mean by preprints is an academic manuscript that hasn't gone through the process of peer review. So that is a curation challenge, because not only has it not been peer reviewed, so you don't know if it's any good, but it also doesn't come with some of the signals like journal name, various impact factor for what it's worth, but things that people use as curation signals. So it is a bit of a challenge. And just to refresh people's memory as to why people do this, why people post preprints, the main thing is to get rapid transmission of results, so people can immediately begin working on the results of new scientific studies while they're undergoing peer review. It's also an opportunity for investigators to get pre-publication feedback on the work to help them improve the papers, which is particularly important for early career scientists who can, this gives them greater visibility and it allows them to make their work available to grant, hiring, tenure committees, etc., long before it appears in this peer-reviewed form. So the history of this archive, launched in 1991, now has, it's a nonprofit funded mainly by Cornell and donations from various philanthropic organizations. They now have more than 2 million preprints, mainly in the physical sciences. We launched bioRxiv in 2013 with the goal of bringing this culture to biomedical sciences. bioRxiv is supported by Chan Zuckerberg Initiative and Cold Spring Harbor Lab, and we have more than 150,000 papers as of now. What's been interesting since the launch of bioRxiv is there's been a real expansion in the number of largely discipline-based preprint servers, SocArchive, ChemArchive, AgriArchive, SciArchive, etc., and perhaps most recently medRxiv, which is an initiative that we collaborate with Yale and BMJ to run. It's much the same as bioRxiv, but more focused on clinical work. For-profit servers have also emerged. Elsevier bought SSRN, and Research Square is an initiative that is that Spring and Nature have a majority stake in. So I think it's really everybody doing preprints these days. And this kind of just illustrates the magnitude of the challenge. This is the growth of bioRxiv up to 2019. I didn't for 2020, 21 because COVID really changes things a bit, and certain things level off, certain things go up and down. But I think what I want to show here is that it is a curation challenge because you just have this growing number of preprints and it's only going to grow. The blue line is the number of submissions to bioRxiv, number of articles that posted. The orange line is the number of revised submissions. So that indicates another challenge in curation of preprints. This shows a preprint on bioRxiv, and you see that there's multiple versions there, which is very distinct from published articles. And of course, there's a link to the published version. So one of the challenges in curation is curating the different versions of articles, which include multiple versions of a preprint and a version that's peer reviewed with a different DOI as a version of record. sorry, yeah, this the other aspect that's important here is that preprints can be withdrawn, just like articles can be retracted from journals. So that's another challenge for curation, is identifying those articles that have been withdrawn and why, and what does that mean. All of this has been particularly important during the pandemic. So when the SARS outbreak happened in 2003, 93% of papers were published after the epidemic had ended. But by the Zika outbreak in 2016, we began to see new preprints arriving amid the epidemic. And then, of course, in 2020, the world really did change, and we saw tens of thousands of articles coming out very early during the pandemic. And it's increasingly, preprints have been an essential means of disseminating information, allowing new developments both in medicine. I'm thinking of things like the dexamethasone papers, clinical trials showing that there was an effective treatment for COVID, and how important was that they came out early. And similarly, basic scientific research that allowed people to get a real head start on trying to find on development of vaccines, understanding disease transmission, understanding what was happening with variants. So it's been particularly important during the pandemic, and this has created its own curation challenges. And this kind of illustrates the importance early on. Right now, you're at a point where obviously there's far more peer-reviewed research on COVID-19 than there are preprints. But very early on in scenarios like this, you saw that actually most of the new stuff was coming out as preprints. And so again, discovery in that large corpus is a challenge. That corpus covers a wide variety of disciplines. Again, this is pre-pandemic, because some of the pandemic data does distort the view, but this is bioRxiv by subject category in 2019. And as you can see, there's a host of different disciplines are covered, the majority in neuroscience and genomics and evolutionary biology, but all these areas of biology are represented and growing. And we anticipate that the same will prove to be true in the clinical sphere once medRxiv gets going in the way that bioRxiv has. So how do people discover papers in this situation? Well, obviously we have search technology across bioRxiv and medRxiv, and there are the standard. We have a Solr-based search that our partners Highwire Press apply to the site, so that's fairly typical of a website. And then we have a whole variety of alerts that readers can use. There's Twitter feeds for all the different subject categories. We have RSS feeds as well, and tailored alerts so that authors can run searches and then get notifications when papers are posted that satisfy those kinds of criteria. We also allow, getting back to that point about the fact that things happen to preprints after they've been posted, we also allow readers to follow preprints, so they can sign up on any individual preprint and decide, whether they want notifications when comments are posted on the article, when a new version appears, or when the article is finally published, or it receives peer reviews from a journal, or is withdrawn. This is certainly not something that we want to limit to ourselves. We produce a bunch of APIs, and most importantly, a text and data mining resource where all the content is posted in an Amazon S3 bucket as XML, so that people can do text and data mining to really help develop community tools to discover information in preprints. And that's particularly important because one of the things that we've always wanted to do, and I think is a critical feature of preprints, is seeing them as part of an ecosystem. And the preprint server is something that enables things to happen downstream, and curation efforts and discovery efforts that aren't limited to the server itself. So for example, you'll see Google Scholar, Crossref, and Semantic Scholar index across bioRxiv and medRxiv. There's a bit of a cautionary tale here because Meta and Microsoft Academic used to, and they've been sunset. So I think that's something that anybody needs to think about in developing tools is where your dependencies lie. So this is just a demonstration of how Google does it. If you do a Google search for a particular paper, you'll see that they have all the different versions of that paper across, in this case, a science paper that previously appeared on bioRxiv, and it looks like there's another instance of that possibly at the author's website. So Google does that pretty well. Of course, they're not going to tell you how they do it. There are other people who probably will, and we seek to enable them in a number of ways. So every paper on bioRxiv receives a DOI, and what is we embed in the DOI suffix the day, year, and month that the paper was approved by the author. That's I won't go into the details. That's basically the submission date, but there's a little bit of nuance there that makes it slightly different. But the key there is that you can from the DOI you can see when the paper appeared, and that's a useful signal, a useful sort of curation signal for readers. The other thing that happens with the DOI record is that it is updated, and the version of record DOI is updated so that the relationship between the version of record and the preprint is clear to anybody who does either. So the bioRxiv DOI record will have the is a preprint of field. You can see the JSON on the right hand side. Meanwhile, in this case, it's an example from the journal Genome Research, and you can see there its DOI record at the registration agency will have the metadata has preprint, and so these two things are connected within that ecosystem. We're in the midst of working with a number of people in the ecosystem to make this work better for things like revisions and withdrawals. There's a number of different ways in which revisions and withdrawals work at different preprint servers. So a Crossref working group has been established with representatives from all the major servers, and we're proposing a series of best practices for updating DOI records for whenever a paper is withdrawn or revised, so that when you use third-party tools to curate and discover the literature, all that information is there and can be surfaced, and those best practice guidelines are forthcoming and should be coming out fairly soon. A further challenge of curation is a consequence of that decoupling, because you get all these commentary and review and different evaluation events that occur after the preprint is posted, and a lot of the time these are by third parties, so they're not within the metadata of the article itself. So I think that we're in an interesting point in the evolution of scholarly communication, seeing a decoupled future in which we do need new tools that will be able to discover both a paper and all these evaluation events. So this is just a few examples of such evaluation of peer community and pre-review are decoupled peer review services. Review Commons is essentially a fairly formal portable peer review initiative run by EMBO. Preprint review is the stage between preprint and publication by eLife, where they will post the preprints alongside an article on bioRxiv, and those peer reviews are from eLife editorial and review. ASAP Bio has a crowd preprint review service. Prelights is a highlighting service for preprints, and we've seen some of these kinds of initiatives to be very important during COVID-19. RC19 from MIT is just one example. The Mount Sinai Immunology Group has another, in which there's very rapid review of newly posted COVID literature as preprints to give signals to people about the validity or lack of validity of the new research. And it's important that those are surfaced and those are discoverable. So, you know, we need efforts that enable people to discover those of decoupled peer review. One of the ways we do it on bioRxiv itself is we aggregate mentions of the paper, be they on Twitter, various blog sites, or more formal review initiatives. And in some cases, as a trusted third party that oversees the peer review process, we use hypothesis annotations to display this alongside the preprint. And this is all aggregated in a dashboard on bioRxiv to help readers discover these different forms of decoupled peer review. We're not the only people who are doing this. There are also third-party services that are doing such aggregation of peer review events around preprint. Society is an initiative run by eLife, with whom we collaborate. Another initiative is Early Evidence Base from EMBO, which does much the same thing. They're seeking to aggregate reviews, evidence, and analysis around unpeer-reviewed information in this new tool they have called Early Evidence Base. Another way to help curate these decoupled peer reviews is the preprint review framework developed by ASAP Bio and others, in which what we try to do is really describe the type of peer review that is happening. Journal peer review is fairly opaque, but we imagine that going forward, these new peer review initiatives will have a lot more transparency, and so it'll be important during curation to understand how the peer review was performed, and what its characteristics were, such as, was it open, was it closed, was it transparent, who chose the reviewers, were they self-selecting it, etc. So I think that's going to be an important signal around curation of peer reviews. One way that we hope this will become machine readable is by use of doc maps. So doc maps are a new group of immutable assertions that are around a document explaining the process by which it was created and how it might link out to other documents. Right now, the pilot has been around peer reviews. We've been piloting it with Knowledge Futures and EMBO around decoupled peer review by a number of different groups on bioRxiv. But you can imagine that ultimately doc maps are things that sit beside peer reviews, the article itself, and various other documents, and basically tell you what the document is, tell you who produced it and how it was produced in the editorial workflow. So this is just a schematic of how a doc maps would work. On the right-hand side, you can see the actual doc map, and on the left-hand side, you can see an illustration of the peer review process, and that this would be encapsulated in the doc map. So ultimately, we hope that tools like this will create a broader decoupled curation ecosystem, and that by having things like doc maps, by having things like the Amazon S3 repository and various APIs and other feeds from bioRxiv and medRxiv, that we can enable this so that other people within the community can participate. So thanks very much. That's all I have on that.
Fantastic, Richard. Very interesting. We have a couple of minutes left for questions or comments. I learned an awful lot. Any questions or comments from anybody? Well, with that, why don't we go to our last talk? Thanks again, Richard. Our last speaker is Lauren Cadwallader. She's the Open Research Manager at the Public Library of Science. She's a scholarly communications professional with experience in academia, libraries, and publishing. So she's in the right place here. Her research background includes anthropology and archaeology. And today she uses her expertise in research and relationship building to advance open research and transparency. And we will hear more about that now. Lauren?
Great, thank you, Mike. Hopefully you can see my screen, my slides, and hear me okay. We'll crack on, assuming you can. So I am the Open Research Manager at PLOS, so I look after kind of various open research-based projects for PLOS across all of our different journals, and especially I look after things related to data and code. So for those of you who aren't familiar with PLOS, we're a non-profit open access publisher, and really our mission is to kind of push forward science by making sure that it's transparent, it's accessible for everybody, and really empower researchers to make that research open and available to everyone. We publish a range of different journals, mostly in the kind of biomedical and life sciences. So we have 12 journals now, and they all have various open access kind of features. Open data is standard across all of them, and then the different journals might have different features depending on their communities and what level of openness that community is ready to adopt. Now I'm going to talk about data sharing, how we can support that today, and really making data open is important because it's one of the reasons why we suffer from science that can't be reproduced. There are, of course, a number of different reasons why science becomes irreproducible, but data is one of those, and so we're really going to focus on how we can make data sharing a thing that publishers really support to try and decrease the amount of research that is spending money from our funders that ultimately gets wasted if it can't be reproduced in the future. So I'm going to talk about 3 different ways that publishers can support data sharing. And I know data sharing is just kind of one piece of the puzzle when it comes to reproducible research, in that we need to put the data out there, but also we need to make sure that it's a high quality data in order to make sure that it can be used. So I just want to talk a bit about today around data sharing, how we can support that, and then think about how some of the issues we've been thinking about around curation and quality can intersect with things we do around data sharing. So the first thing I want to talk about is aligning publisher requirements and helping to create change as a group of publishers and a body together. So first of all, policies have been in place for sharing of specific data types, such as protein structural data, for decades. That's a great start. And in the last 10 years or so, we've seen more and more publisher policies come into force around data sharing, including PLOS in 2014. So we have a mandatory data sharing policy. All data that supports a publication must be shared. Papers must carry a data availability statement that describes where that data can be found. Unless, of course, there are ethical or legal restrictions that prevent that data sharing. So there's just an example of a data availability statement there at the bottom of the slide. It shows you the kind of detail that we look for in those data sharing statements. But the growth in this publisher policy around data sharing has created a kind of multiple similar but not necessarily identical policies. Again, also using similar but not necessarily identical terminology or frameworks, as kind of Alison was alluding to in her talk earlier. This can lead to confusion, and it can also lead to unequal levels of support, especially for researchers who are also having to deal with funder policies around data sharing, as well as institutional policies. And then you have the publisher laying another potential requirement around data sharing on top of that. And different institutions can support that in different ways. So it really becomes a bit messy for researchers who aren't necessarily sure what they need to do in order to share their data and comply with what publishers or funders want, which creates, a barrier to them sharing that data well. And really, we want them to share their data well, so we want to reduce those barriers. So what publishers can do is try and align themselves. So Alison mentioned the Research Data Alliance group that is working to standardize policies that publishers have around data sharing. And there's just a citation up there to one of their recommendations that looks at the different types of policies that publishers could implement, from the kind of encouraging ones for publishers who aren't quite there ready to make a mandatory policy yet, all the way through to mandatory policies. And really, by standardizing things across publishers, we can start making life a bit easier for those researchers, but also it helps funders that align policies as well as institutions. And as I mentioned at PLOS, we have a mandatory data sharing policy, and this is something we would really encourage other publishers to think about and kind of push forwards with, because it has a great effect on the amount of data shared. So on this slide here, you can see the number of articles at Biomed Central in the blue and PLOS in the red that have a data availability statement, and then the lighter blue colours are the different types of statements they have around data sharing. And before Biomed Central introduced a mandatory policy around data sharing, we saw like a 5% compliance of researchers who would voluntarily share their data and put in a data availability statement. But you can see after the kind of black line on the graph around 2015, that number of dark blue kind of articles, the ones without a data availability statement, really drops down because a mandatory policy comes in. So researchers are really forced to share that data, and actually they seem happy to on the whole, and will give different levels of information. We'd always encourage the most detailed description. So mandatory policies do really have a great effect, because otherwise we have a very low voluntary amount of data sharing. So it leads me on to my second point, where I'm going to stick with that data policy theme just for a moment longer. So we can work as publishers, we can work with community initiatives and infrastructures around data sharing, because actually policy compliance on its own is really costly. Stronger policies, of course, will require more resources to enforce them and make sure that researchers are doing what they should be. So if we take PLOS as an example, it takes us around 24 minutes per paper to check that the data policy has been adhered to. And that's really just kind of the bare minimum of checking the data policy. That's checking that there is a data availability statement and it has links, and those links resolve and they go to the data that, you know, it looks like it should be that data for the paper. There isn't anything around checking the quality of the data at that point. And so you can imagine if we started doing kind of quality checks as well, that 24 minutes is going to creep up and up and up. And we already, know that there are problems in the publication system, that authors waiting for their papers to be published. We have only limited number of academics who are willing to serve as editors or reviewers. So we really don't want to burden the system any more than we have to. So what we can do instead is guide researchers to the right repositories, so that the repositories can assist researchers with their specialist knowledge and domain expertise in order to help share that data in the correct way. And so one way we do this, as an example, this is PLOS Biology and some text from our recommended repositories page from the journal. And what we can do is recommend the best places for the types of data we expect to see in that journal. So I've just highlighted a couple of passages. The top one, pointing authors to domain-specific repositories like GenBank or Array Express. And then the second one, pointing authors to community standards, such as the ones listed on Fair Sharing that we heard about earlier. So we can really work with existing community infrastructures and projects and repositories to really push researchers to the right place, for the best place for them and their data. We can also enhance our infrastructure as publishers. So we can do things like partner and integrate with data repositories so that they can be used as part of the submission or maybe the peer review process. And that in turn will increase repository use. So this has many benefits. It makes it easier for the author to submit the data if they can simply go to the journal submission page, do their journal article submission, and also access the data repository at the same time. They don't have to necessarily interact with different systems at different times. They can go to kind of one-stop shop place. It has the benefit of making it easier for reviewers and editors to access the data, because once they are within the journal submission system reviewing the paper, they can click through quite easily into the data that has been linked to from the submission system. Again, so it decreases the amount of places that they have to go looking for different links and data. It's great for both the authors and the journal, because the data repository can handle that curation step. So it can really add some benefit there for the authors, and the journal knows that the data is being looked after properly. And it also benefits that data repository because you get a larger corpus of data going in. And so it becomes a larger pool of knowledge for researchers to look for stuff that's relevant for them. This does require some changes to third-party systems such as Editorial Manager, which is the Submission System PLOS uses, or other ones like eJournals Press. And that does have some cost considerations, but actually the longer term benefits, I think, are well worth it. And just as an example, at PLOS Pathogens at the moment, we're trialing one of these integrations with the Dryad digital repository. And so this is a generalist repository rather than domain specific. So we're not curating huge data sets or anything at scale with this, but we are learning about researcher workflows and actually how this type of integration works for them, and that we can make sure that we're there offering the tools and technology they need at the right times and with the right support and information. So we can also enhance the scholarly infrastructure for readers as well. So it's not just authors that we want to benefit from data sharing and take advantage of the benefits of the curation and the data sharing that has happened. We can increase the discoverability of research data that is associated with published articles. So this might be by doing something like putting a widget into an article, as the example on the slide shows, so someone can have a quick look at the data without having to leave the article page. But also there's a lot of important work around linking of metadata between the data and the article and vice versa, making sure those links are bidirectional and that the data can easily be found as well as the article that explores that data more easily. So there is always work to be done to ensure that those links are clear and where they should be and comprehensive. We can also try and incentivize sharing, and we can do this through a number of different types of community initiatives as well, to make sure that a kind of incentivization is across all different publishers, and so that researchers become familiar with these and understand the benefits and want to share their data, all publishers, with whoever they're publishing with. So one thing is data citation initiatives, so really encouraging researchers to cite their data properly, so it's considered a first-class research object, and that the data is just as important as the paper itself, and that people can go directly to the data from that citation. So not only are they citing it, but the journal is handling that citation in such a way that it can be measured. We can look at metrics around that and understand the usage of the data set itself, rather than just the research article that's associated with it. So the Make Data Count initiative is looking at these data metrics, and is one thing that publishers can support. We can make incentives for authors, such as the Centre for Open Science, badges to demonstrate that data has been shared in such a way. And again, that's been shown to get authors to share more of their data in journals that employ these badges. So it really does seem to have an effect. And if we can share the data, then that's step one to then making sure that we have really high quality data. And of course, there are criteria around the open science badges that looks at kind of levels of data curation, making sure all the data is there to make it reproducible. And then we can incentivize readers as well. So we can aid discoverability. So I was saying before, making it easier then to discover the data, and that encourages engagement with the data. And if people are engaging, they're more likely to reuse that data. And we'll be launching a new feature on our PLOS journals tomorrow to encourage and incentivize readers to engage with the data, and we'll be happily reporting back on that in a few months to see how that's gone. And we'll be doing that in an automated way to try and make discoverability and engagement with that data much more automated, so we can employ it to a lot more articles, and again reduce any workload burden that there might have otherwise been on authors or editorial staff. And then finally, I just want to touch upon how we can enable peer reviewer engagement with data as a way to support curation with that data and data sharing. So not all journals and peer reviewers are going to be motivated to request the data to review, or even review it at all if it's already there. But if you make it easier for the reviewers to look at that data, it does increase their engagement with it. And that's where those kind of technological integrations to make it much easier for reviewers to find their data are really helpful in that regard. It does, or it could involve systems, so like the technology route, policies, so saying actually reviewers have to look at the data, or just mere guidelines to help reviewers understand what their duties are around data review. So just an example from PLOS One paper here then, we ask authors to specifically call out where they share their data. So that's their spotting box on the screen here to make it easier for reviewers and editors to then check compliance. And then when we ask reviewers to report back on the manuscript, we ask them if the data policy for PLOS has been fulfilled, and they say, yes, it has, or no. So it's really clear if anything needs to happen in regards to data sharing further down the workflow. And back to that RDA group I was talking about earlier that came up with some data policies for publishers. They've also come up with some questions that can be asked around the peer review of data. So there are two sides to this. First, looking at those data availability statements and seeing if the right information has been provided, but also looking at the data files themselves. But now if we're partnering with repositories and integrating with them and encouraging authors to submit their data set repositories, some of these questions might then become redundant and some of the work is done for the peer reviewers. So actually that really benefits the publisher as well as those benefits to authors and the repository I mentioned earlier. And it creates a really nice feedback loop where we're all working together to really make sure that the data is there and it's supporting the publication. So that reduces the burden on reviewers and helps the journal to ensure that the data has been shared how it should be. And of course, if a different repository is being used, we can of course go through these checklists, or perhaps journals want to create checklists or guidance that is really discipline specific, and we can work with communities to create that really specific guidance. So finally, I just wanted to end by, I guess, reiterating what some other people say, that we are just one piece of the puzzle. If we all work together as a community, as publishers, as infrastructure providers, as people coming up with standards and guidelines, then we can really create a good ecosystem for sharing data and sharing that data well. And I will leave it there. Thank you very much.
Well, thanks so much, Lauren. That was great. There are a number of questions we've got, and we do have about 3 minutes. I'll read the first one. So the first one's from Dawei Lin, and he asks, which repositories are currently working with PLOS to help with data review? And how does a repository not working with PLOS collaborate with PLOS nonetheless?
So I'll answer the last question first. So if you're interested in working with PLOS on that kind of data review, the best thing to do is probably send me an email. So I'm the person who kind of deals with a lot of the data initiatives. So I'll be best pleased to kind of to discuss with you what we could work together with and connect you with certain editors if it's one specific journal that you're interested in. And I can put my email in the chat in a minute. At the moment, we are mostly working with the Drive digital repository. And so we're not using any specific domain specific repositories. We don't have a close integration with any. We're working more with Dryad to look at the workflows, and then they provide curation for our data sets that are accepted for publication. But actually all of our journal teams have really subject expertise, and they have like I was showing on the PLOS Biology page, we recommend certain different repositories for those journals, and our editors are all quite familiar with those, so they can offer kind of more detailed and specific advice to researchers if they need support around data sharing.
Great. Well, thanks for that. Another question. Would you consider incentivizing or otherwise networking with the community of data managers and curators at academic institutions? They're often in positions where they can help with repository choice, curate data, and maybe be able to provide more robust curation in institutional repositories that's then is supported by generalist repositories.
Yeah, I mean, I definitely would. So before I worked at PLOS, I ran a institutional repository. So I know firsthand what kind of support can be given at institutions. And yeah, definitely we would look to kind of work with institutions where they wanted some help or wanted to learn around the publisher workflow a bit more and how we can intersect. And also, we're really interested to hear more from them and learn more about their communities and what kind of support they need from publishers. I think, of course, there are lots of institutions out there and we can't work with all of them individually. So it would be, it'd be really great if there are kind of consortia or groups of institutions or groups of institutional libraries who come together, who we could perhaps form working groups with. And again, my email's in the chat. So I'd really be happy to work with institutions. And I think they do have a lot to offer, especially now that there is ever increasing support around data curation for researchers in institutions. I do think it's a really key piece of the puzzle that has often been missed a bit, I think, in the past.
Yes, and there was actually another question that was very highly relevant to that. So I'll skip that one. I'll go to this one from Yan Li Wang. And she asks if you could share your perspective from a publisher's point of view on actionable items for publishers and NIH to work on together in support of implementing data sharing and data management policies like the new one from NIH.
Yeah, sure. I think, as I was saying before about aligning policies, it's really, I think, important that we use similar language and terminologies when it comes to what funders require and what publishers require, and that we as publishers, if we get any pushback from researchers going, I don't want to share this, or I don't think I should have to share it in this level of detail, we can go back and say, what, your funder requires you to do this, and you said that you would do that in your data management plan. So that we're backing each other up by using kind of similar policies and terminology, and that we're not seen as ganging up on the researchers either, but we're working together to provide support for them to fulfill those requirements.
Exactly. So Xiang Lu asks, or he says, providing data in standardized nomenclature, such as SwissProt or NCBI gene database identifiers, would help to improve article discoverability. Is there a plan for PLOS to encourage authors to help provide that?
I don't know on that point specifically, there's a plan, but I can certainly take it back to our journal editors. That's the kind of in-depth experts kind of knowledge that they'll have on what works best. But yeah, we would certainly, and we definitely do encourage the standardized use of nomenclature around for any standards really that we're publishing, and we would definitely encourage that. And some of the work I'll be doing later this year is really reviewing kind of what are the areas where we can improve, and perhaps take things like that, which our editors will have kind of the specific knowledge around, and really make sure that we're enforcing those kind of best practices. So we're moving beyond just sharing data to encouraging and enforcing better practices with that data sharing.
Great. And we've got one final question. This is from Helen Parkinson, and she said, not all publishers have the rigor that PLOS does, and most repositories deal with multiple publishers. How can you encourage other publishers to adopt some of your practices?
I think we try to lead by example, so showing that we can have these policies and that it doesn't affect things like submissions or the kind of quality of the research that's coming in, so it doesn't damage our publishing endeavor from like a business point of view, because no publisher wants to implement a policy and then lose submissions and lose revenue and not become sustainable in that regard. But I also think when we demonstrate the benefits this has for authors and science, and then ultimately the journal and the publishing endeavor on top of that, are really powerful, and in showing that actually this is improving science, that things are getting better because we insist on these kind of things. And then also that it's not all down to the journal to make sure that these policies work, or that the researchers are doing things, but we can work together, we can work with communities, and that there is support out there for us. And it's not just us making up the rules, but we're working together, and actually the community want this from us, and that some are really keen for sharing and would really like to see improved practices, and that the funders want to see that as well.
Well, actually, there's one last question that I'll ask that I think is really a crucial and important point. And the question is there a publisher standard for how data is cited
Yes, there is, and it will be in one of those references I've used. So yeah, there are kind of standards for data citation. I'm just really trying to think of the citation off the top of my head, and I can't. Perhaps if someone else is online, they can put it in the chat. But yeah, there's certainly ways to cite the data with the authors and the repository. Oh, thank you. Someone's put it in the chat. And we would definitely encourage everyone to use.
Yes, so Anita DeWard just put it in the chat, and it comes from Force 11, a
Thank
very
you.
important force in open scholarship and science. And with that, let me thank you, Lauren, and let me thank all of our presenters this afternoon.